Hello, it's Miss Kelly here with
Miss Bauer.
And we are going to tell you all about the periodic table of elements.
Of the elements.
Of the elements, whatever.
This one's not going to be good. We already talked about that. This should all be review. Well, a lot of it's review, which is nice because then, yeah.
Review for my class, too.
Yeah. An element is made of only one kind of atom. I feel like that's been on like our last 2 quizzes. So, okay, we're going to talk about 2 old people, old dead people, and then we're going to move on really fast. So the first one actually has an element named after him. It's Dmitry Mendeleev. He lived in the 1800s. He's the first scientist to successfully publish about the relationship between the elements. And he arranged his periodic table according to atomic mass. So, yeah.
Which, of course, we all know is not how the periodic table is arranged today because this guy, Henry Moseley, came along.
Just a little bit later.
Yes, a little bit later.
And he died kind of young.
Oh, poor guy.
I know.
And he arranged the periodic table correctly by atomic number.
Yay.
Woo.
Okay, so here's the periodic table. Columns on the periodic table are called groups or families.
Rows on the periodic table are called periods. There's a period at the end of the sentence. You write the sentence horizontally. That's how you remember it.
Oh.
You like that, don't you, Miss Bauer?
I do. If we'd practiced that, I would have known that was coming.
There you go.
All right, there's 18 columns or groups of families and 7 rows, and we're going to talk about each one. Before we do, we're going to review the element box. Do you want to take this?
Yes. So in the element box, we have the element symbol. Remember that when there are 2 letters, the second letter is lowercase. We also have the element name right there, radon. The atomic number, which tells us protons and neutrons.
Protons and electrons.
It's 3:30 in the afternoon. I'm tired. Sorry,
Not
guys.
neutrons.
Protons and electrons. Jeez. And then the atomic and then the atomic mass, which is protons plus neutrons.
Right.
Was that right?
Yeah.
Okay, good.
I mean, or it's the average and all that stuff we haven't gotten to yet. Okay. So, group 1, all the way on the left. This first column right here. All right, the alkali metals. They're the most reactive metals on the periodic table. They have 1 valence electron. Don't worry, I'm going to come back to it. Valence electron are the electrons in the outermost shell. You guys, are the outermost like cloud? Because you guys only.
They're the furthest from the nucleus.
All right.
Yeah.
2
energy level. Sometimes I say energy level too.
Okay, so shell or energy level. So they only have 1 that's really, really far away. So they're likely to lose their 1 valence electron to become an ion with a charge of +1. And we haven't talked about ions a whole lot.
Well, my class is all about ions.
Fantastic.
They know that ions are atoms that have lost or gained electrons. So their charge is no longer 0 or neutral. If they lose electrons, now they have more protons, so their charge is positive. And if they gain electrons, obviously now they have more electrons than protons, so they end up with a negative charge.
Yeah, that's all good. So that's the alkali metals. Most reactive, 1 valence electrons, which they tend to lose to be an ion with a charge of +2.
Column number 2, or group 2, those are the alkaline earth metals.
It actually goes further down, but I can make it work.
They have 2 valence electrons, which you already know, and they tend to lose those 2 electrons to become an ion with a charge of 2.
Positive 2.
Positive 2, yes.
I make mine be very specific.
Yes,
but they're
positive 2. Listen to Miss Bauer.
Groups 3 through 12. All of these. Whoa, you thought it was going to take a while. We were going to go through all 18 valence electrons. So they don't lose or steal. They just kind of share. They use this sea of electrons. So all the electrons just kind of float around between the different nuclei. And they kind of can't keep track of whose is whose.
But they do still bond with other elements, right?
Yes, they do.
That's why they share. Boron family. They are not boring. Haha.
Little
science joke.
She made a joke.
The boron family has 3 valence electrons. So they tend to lose those 3 electrons to form an ion with a positive 3 charge.
Good job. All right, group 14 is this group right here. It's the carbon family. They have 4 valence electrons, and we saw this pattern because we all did that same packet.
Yes.
Yeah, so they have 4 valence electrons. They can either give away or take. So if they give away 4 electrons, they're going to have a charge of -4. But if they take 4 electrons, they're going to have... Oh, wait, did I mess it up? only we
You
could pause
too.
it and start over.
You do these in the morning.
I was like looking at it and I was like trying to. Okay, so if they give away 4 electrons, they're gonna have a charge of positive 4. Oh, see, it does line up. Like give away positive 4. If they take 4 electrons, they're gonna have a charge of negative 4.
That was smart of you to do that.
I know. If only I had paid attention to the way I'd written it, it would have been very helpful.
All the students know that anyways. They don't need us.
Yeah.
Group 15
They like it
is
when we mess
the nitrogen family. The nitrogen family has 5 valence electrons. They tend to steal 3 electrons from other atoms to make bonds so that they have 8. And when they steal those 3 electrons, now they have 3 extra electrons, which gives them a negative 3 charge.
Okay. Group 16 is the, I don't know if you guys go with the oxygen family, but we also called them the chalcogens, so that when they get to high school, they can sound
Will you
really
say
smart.
that word again?
Chalcogens.
All right, cool.
Yeah.
Yeah.
So they sound smart.
Yeah.
Sounds smarter than the oxygen group.
Write that down, my class.
CHALCOGENS. Okay, they have 6 valence electrons because we're going with the pattern. So to get to 8, they steal 2 electrons from other atoms to make bonds or form ions of -2 because they have those 2 extra electrons, and electrons are negative. I feel like we repeat things a lot, but that's probably helpful.
And here we are, yes. Yeah. Here we are at group 17, the halogens. They are the most reactive nonmetals because they have 7 valence electrons. So all they have to do is steal 1 electron in order to form their bond. So when they steal that 1 electron, they end up with a -1 charge.
Because electrons are so small. They're so easy to steal.
And, yeah, okay, cool.
No.
I don't have anything to add. So.
Oh, okay. I'm glad I got this one because my class already knows this is my favorite group. Group 18, the noble gases. Oh my god, I spelled it wrong. Isn't it L-E?
I always do that. It is LE.
Okay, this is spelled wrong. Ah, crisis. Okay, so the noble gases. They have a full outer shell of electrons. So they're non-reactive. They don't need to steal anything. They don't need to give anything away. So they don't want to play with anybody else.
Fabulous.
Noble, because they're noble. Okay, and these 2 on the bottom we're like not going to talk about. We're just going to tell you their names.
The lanthanide series.
That's
Remember that they go in the middle of the table. Are they? No, they're not transition metals. Never mind, go.
And then the actinide series, which is on the bottom. These are rare earth elements. A lot of them have only existed in the lab, and we haven't found them. So don't worry too much about those. Just know their names. Okay. Periodic trends. We're going to go through this first one really fast because we don't really care about it anymore. Atomic radius. As you move left to right on the periodic table, the atomic radius decreases. As you move top to bottom on the periodic table, the atomic radius increases.
But you really don't know that it increases as you go down a group because the atoms get bigger.
Oh, sorry, I went too fast.
And the most reactive metals are on the left. The most reactive nonmetals are on the right, except for, of course, the noble gases. You spelled it right that time.
I know, I got really excited. Is it sad that this is a year old and still spelled wrong? Okay, speaking of metals and nonmetals, this line separates them. So
I called it the zigzag line or the stair-step line.
I call it
in
the
my class.
stair-step.
Yeah.
So metals fall to the left of this line. Nonmetals are to the right of this line. If an element is touching this line, it's a metalloid.
Except for aluminum.
Except for aluminum, that it just is a metal. But anyway, so here's your periodic table. Here's your stair-step. So anything to the left of this line is going to be a metal. Anything to the right is copper over here on the left. Like, you know those are metals.
Right. That's
So
the
it's,
point.
like, really helpful.
That's a very good point.
Okay, this was long. We should just stop.
All right, bye.
Okay, bye.